The probability that a biased dice will land on a 5 is 0.3. Megan is going to roll the dice 400 times. Work out an estimate for the number of times the dice will land on a 5. So the estimate then? Well, there's 400 throws, and for each of those throws there's a probability of getting a 5 of 0.3. So 400 times 0.3 then is 120. So in 400 throws, we'd expect 120 of them to be a 5. So that's 120 is the estimate. Bob asks each of his 40 friends, so the total is 40 here of the frequencies, how many minutes they took to get to work. Here's the minutes. The table shows some information about his results, and here's the frequency, the number of people, which totals 40. Work out an estimate for the mean time taken. Mean time estimate then. Well, let's work out an estimate for the total number of time taken to get to work by all the people and divide it by 40. So the time for all of them to get to work divided by 40 will give an average, the average time to get to work. So here we've got 3 people, and this between 0 and 10, the midpoint here of this interval, is 5. So 3 5s. 3 people take 5 minutes. Say 8 people take 15, isn't it? Is the midpoint there. And then 11 people take 25 minutes. And then 9 people take 35, say. And then another 9 people take 45. Choose the midpoint again there. And see what we get. Let's type it in the calculator. So 3 times 5 is 15, so I'm just going to write 15 plus 8 15s are 120, so I'm just going to write 120 plus 11 25s is 10 is 250, and another 25 is 275, so I'll just type that in there, plus 9 times 35, 10 35s are 350, and 35 less is 315, so I'll just put 315 there. Plus, and then same here, 450 less 45 is 405. So I just put, rather than type out the long-winded calculation, just put the numbers in. 1130, and then divide that by 40 equals decimal 28.25 is the mean time then. 28.25 mins. 28.25 minutes.